going to be taking a look at the characteristics and identification of quadratic functions. And how do you identify a quadratic function? First, a quadratic function is the parent function y is equal to x squared. It's in the form y is ax squared plus bx plus c, where a, b, and c are integers, and a is not 0. When graphed, a quadratic function will make a U shape, which is called a parabola. That parabola is going to have a very top or very bottom. That highest or lowest point in the parabola is called a vertex. When y is equal to 0, that graph will cross the x-axis, its x-intercepts. That is the 0 of a function, or when 0 is equal to ax squared plus bx plus c. We can tell whether or not that parabola will cross the x-axis using the discriminant, b squared minus 4ac, which are its x-intercepts. If b squared minus 4ac is 0, there's one intersection. If it's greater than 0, it intersects the x-axis twice, and if it's less than 0, it will not intersect the x-axis. The axis of symmetry can be found through the equation x is equal to negative b over 2a. That is a line that moves straight up and down the center of the parabola, so it looks like it's reflected across it, which I'm pointing out here on the graph with that red line back up on the parabola picture. Here I have the equation of a polynomial. Y is x squared minus 4x minus 5. I'm going to attempt to graph this using techniques that we've learned well back in algebra. The first thing I notice is that the y-intercept we defined as when x is equal to 0. And if x is equal to 0, then y is negative 5. So I'm going to place that y-intercept of negative 5 on the graph. That means to me that there's two locations where y can equal negative 5. Because up here and well back when we learned about the distributive property, we learned that you can do the distributive property backwards. And the distributive property backwards is when I take out something that they have in common. Now what these two have in common is an x. So I'm going to take an x out of them, leaving me with x minus 4. So what I can see is the two values where y will equal negative 5. If x is 0, this whole thing goes away. But also, if x is 4, the whole thing goes away. So I have found a point where things are symmetric, when x is 4 and when x is 0. So I have 2 points to graph my polynomial. Now what I need to know is where is its vertex. To find the vertex, I'm going to want to find the axis of symmetry, which is simply the middle. So I'm going to count my way into the middle, and I find that my axis of symmetry will occur when x is 2. Knowing what my axis of symmetry is, knowing an x value, all I need to do is substitute in that value into my equation. So I can say that y is 2 times 2 minus 4 minus 5. And 2 minus 4 is negative 2, and 2 times negative 2 is negative 4. So negative 4 minus 5, y will be negative 9. So here's my point. That is x is 2, y is negative 9, and that is my vertex. At this point, I have information that will help me draw my parabola. Now, the only thing that I haven't gotten from this piece of information is what are my two x-intercepts. That's where some other techniques are a little more useful. We'll take a much more algebraic approach to how to do this. So to graph this polynomial, what I would like to find is its y-intercept. Again, y-intercept is when x equals 0. And if x equals 0, y is negative 5. So I have my y-intercept on the graph. I'd like to find my axis of symmetry. My axis of symmetry, remember, is found through the equation that x is equal to negative b over 2a, which means that x is negative times negative 4 over 2 times 1, meaning x is 2. So when x is 2, that is my axis of symmetry. That is the mirror point of this graph. Just like in the other technique, what I'm going to do in order to be able to find my vertex is I'm going to substitute that value into my original equation, giving me that y is something squared minus 4 times something minus 5. And that something is my x is 2 value. Once I know that x is 2 is substituted in there, all that's left is for me to calculate. I'm going to get that y is equal to 4 minus 8 minus 5, and 4 minus 8 minus 5 is negative 9. So I can graph that onto my graph here, and I get the point 2 comma negative 9. That is my vertex. What's left is to be able to graph it, but at this point I still do not have my x and y, or my x-intercepts. What I need to be able to do is take that equation, y is x squared minus 4x minus 5, and solve it for when y is 0. So looking at this same equation, I can now factor it. Now factoring these polynomials is something that we're going to get into here shortly in the next couple lessons. But what I have is x minus 5, x plus 1. Again, I'm going to show you in detail how to do this in just a couple lessons. The zero product property means that if x is 5 or x is negative 1, then y would be 0. So I can have my negative 1 on the line, and I can have my 5 on the line. This gives me all the points needed and all of my points of interest to graph my parabola. It's going to come down through each of these points, and hopefully you draw parabolas a little better than me. And this is what we wind up with. Now this is a much more algebraic method. At this point what I'm showing is just simply the original work that I did in order to be able to graph this and show everything. I'm really doing both of these techniques at the same time. Math is an open book. You should read it. There's a lot of understanding to be had there.